In this unit, we're going to learn a little bit about the systemic mycoses. Coccidioides immitis is the organism that causes coccidiomycosis. This organism under the microscope is fairly characteristic. It has thick-walled, barrel-shaped arthroconidia. You can see those readily in the picture. There's no yeast phase for this organism, but when it's at 37 in the human body, it forms a spherule. These spherules are large, round, thick-walled, and inside you can see the endospores. In today's world, it's good. We have other ways to diagnose this guy other than culture. There are some DNA probes available, and we can also do immunodiffusion for the antigen. Um, this guy is nothing to sneeze at in the lab, no pun intended. These arthrochondria are very infectious, so even though you're going to handle all fungal cultures in a safety cabinet, it's kind of a double way. You make sure you handle this guy in a safety cabinet. And these arthrochondria in the lab are so problematic that they do not even want you to make a slide culture. Remember, the slide culture is where you take a little cube of agar and then inoculate the edges of the cube of agar with the organism. This is on a microscope slide. Then you cover slip it, and then you let it grow, and then you make slides from the cover slip and from the original slide. It's just too dangerous to manipulate this guy in this manner. This picture cracks me up. His colony morphology is described as variable. So take a gander at these and ponder that this is all the very same organism. So here's what they would see in a tissue section. These spherules, thick wall with endospores inside. And this is diagnostic for Coccidioides immitis. Cocci is endemic to the desert southwest of the United States. If you work in that part of the country, you're going to run into this organism. Having never worked there myself, I've never seen him in person because I've always practiced in the Midwest. We're leaving cocci behind and looking at an organism known as Blastomyces dermatitidis. This organism causes blastomycosis. This is a slow grower. We want to make sure the plates are held for a full 8 weeks if the physician suspects blasto. Because it's such a slow grower, it is doubly important that specimens coming into the lab are processed immediately. We discussed early in the semester how in general this is important with fungal cultures so that the pathogen doesn't get overgrown by either bacteria in the specimen or rapid growing fungi that grow up first and then prevent the pathogen from growing. This is a dimorphic fungi. If we look over here, we see this is the yeast form, which grows in the human body at 37 degrees. And what is found in the soil is the mold form. And of course, dimorphic means that, this thing flops back and forth from yeast to mold based on the location and temperature that it's growing. Under the microscope, we see septate hyphae, long or short conidiophores, round or pear-shaped conidia, and lollipop is something you want to associate with blastomyces. And this is a very good picture showing us what they're referring to when they talk about these lollipop conidia. The other thing it's important to associate with Blastomyces dermatitidis is broad-based bud, BBB. Here is the yeast form. Obviously, it's budding. And see this area between mother cell and daughter cell is broad or wide. So that's an important distinguishing feature for Blastomyces. Other tests that are used in modern days to identify this guy, DNA probes, and testing for various antigens. that are found on the organism. Whenever you see a test, like this, where we've gone above and beyond the old-fashioned long culture and identification technique into DNA probes and antigen testing, that's a clue. This is a considerable pathogen. It's an important one. We want to get it diagnosed accurately and as rapidly as possible. We don't want to have to sit around for weeks like we did in the old days. Here we see a colony of Blastomyces dermatitidis. It's described as initially yeast-like, and then it becomes white and cottony, then becoming brown and tan as it ages. That's if we grow it at room temp. If we incubate a culture at 37, we're going to have cream to tan, waxy, yeasty looking colonies. Histoplasma capsulatum is the organism that causes histoplasmosis, or histo. Histo comes in a variety of forms, everything from asymptomatic to symptomatic to full-blown lethal. So it's an organism to be aware of and be cautious that you don't pick it up. The reason I stuck the bat picture in here is because bats and other birds are known to carry this organism. It doesn't make them sick, but they pass it in their feces. So particularly with the bats, I know sometimes we have to deal with bats, i.e. you might get a bat infestation in your attic. I've had one in the past myself. And bats are good guys, in my opinion. They take care of the insect population around your house. But don't try to clean up bat guano, which is just bat feces. Don't try to do that by yourself. You want to call in the experts if you need to clean bats out of your attic or what have you, because they've got the appropriate respirators and protective equipment, and they know what they're doing, so that you don't want to take the risk of picking up this thing. Okay, what it looks like clinically, pretty non-descriptive. The particular lesions. This can be on the skin, inside the mouth, in the lungs, which is the lethal form. Pretty much any body tissue, I believe, is fair game for contracting histoplasmosis. South central and southeastern parts of the United States, as you can see from the epidemiology map, it is endemic, and indeed highly endemic in some areas. So once again, if you're living, working in these areas, know that histoplasma is not only potentially something that you could catch if you're not careful, but also something that you may be culturing and growing in the lab. Histoplasma is an intracellular organism. So this is a real nice photo showing the organism that is inside macrophages. The macrophages phagocytize it, engulf it, take it in, but typically can't kill the organism, and so it reproduces within the cells. Paracoccidioides brasiliensis causes paracoccidiomycosis. I'll let you take a look at the microscopic morphology and the descriptions. The one thing I want to bring to your attention specifically to associate with this organism, the little tag term, ship's wheel. If you think about what the steering wheel on a ship looks like, and you look at this, it's faintly reminiscent. I mean, not really, but yeah, when you think about the fact that a ship's wheel generally has those spokes radiating out. So what happens with this organism? We get these large, thick-walled cells, and then they throw out multiple buds around the outside edge. So associate ship's wheel morphology with Paracoccidioides brasiliensis. And our last organism today is Penicillium marneffii. This is considered the only species of penicillium that is a true pathogen. By true pathogen, we mean that It will make healthy people sick. It does not depend on an immunocompromised situation in order to establish infection. In people who are severely immunocompromised, such as people with HIV/AIDS, it often progresses to disseminated disease, which is fatal. This is also the only penicillium species that is dimorphic, able to grow as a yeast form at 37, mold form at 22. I think this is a nice little review slide, putting these dimorphic fungi side by side. Of course, Sporothrix schenkii, we talked about last unit, rose handler's disease. We learned these cigar-shaped budding yeast cells for him. This week we learned about Paracoccidioides brasiliensis. There's our ship's wheel budding yeast cells. Coccidioides up here. We talked about barrel-shaped arthrospores. Now, these aren't really arthrospores yet because they're not broken apart, but they do give you the sensation that when they do separate, they're going to be kind of boxy or barrel-shaped. Blastomyces dermatitidis, we learned the characteristic broad-based buds, which aren't illustrated really well with that drawing, but you get the idea. And here's one more nice graphic of the dimorphic fungi that we've been looking at. Remember, these guys are true pathogens, which is why when you go back and review, you'll see that there are DNA probes available today to make a quick, definitive diagnosis. So I like this one because it's emphasizing the tissue spherules for coccidioides, the barrel-shaped arthrospores. Again, this doesn't really look like a broad-based bud. I think they could have done a better job with drawing this guy. But then down here with our Paracoccidioides brasiliensis, our ship's wheel configuration.